in most topics, you have to get pretty advanced before you start addressing the philosophically interesting things. But in chemistry, it just starts right from the get-go with what's arguably the most philosophically interesting part of the whole topic, and that's the atom. And the idea of an atom is philosophers long ago, and you could look it up on the different philosophers who first philosophized about it. They said, hey, if I started off with, I don't know, if I started off with an apple, and I just kept cutting the apple. Let me draw a nice looking apple just so it doesn't look just like a heart. Or there you go. Have a nice looking apple. And you just kept cutting it, smaller and smaller pieces. So eventually, you get a piece so small, so tiny, that you can't cut it anymore. And I'm sure some of these philosophers went out there with a knife and tried to do it. And they just felt that, oh, if I could just get my knife a little bit sharper, I could cut it again and again. So it was a completely philosophical construct, which frankly, in a lot of ways, isn't too different to how the atom is today. It's really just a mental abstraction that allows us to describe a lot of observations we see in the universe. But anyway, these philosophers said, well, at some point, we think that there's going to be some little part of an apple that they won't be able to divide anymore. And they call that an atom. It doesn't have to just be for an apple. They said this is true for any substance or any element that you encounter in the universe. And so the word atom is really Greek for uncuttable. Uncuttable or indivisible. Uncuttable. Now we know that it actually is cuttable, and even though it is not a trivial thing, it's not the smallest form of matter we know. We now know that an atom is made up of other more fundamental particles. And let me write them. So we have the neutron, and I'll draw in a second of how they all fit together in kind of the structure of an atom. We have a neutron, we do have a proton, and we have electrons. Electrons. And you might already be familiar with this. If you look at old videos about atomic projects, you'll see a drawing that looks something like this. Let me see if I can draw one. So you'll have, something like that, and you'll have these things spinning around that look like this. They have orbits that look like that, and maybe something that looks like that. And the general notion behind these kind of nuclear drawings, and I'm sure that they still show up at some government defense labs or something like that, is that you have a nucleus at the center of an atom. You have a nucleus at the center of an atom. And we know that a nucleus has neutrons and protons. Neutrons and protons. And we'll talk a little bit more about which elements have how many neutrons and how many protons. And then orbiting, and I'm going to use the word orbit right now, although we'll learn in about 2 minutes that the word orbit is actually the incorrect or even the mentally incorrect way of visualizing what an electron is doing. But the old idea was that you have these electrons that are orbiting around the nucleus, very similar to the way the Earth orbits around the sun or the moon orbits around the Earth. And it's been shown that that's actually a very wrong way, and there's a lot of and when we cover quantum mechanics, we'll learn why this doesn't work. What are kind of the contradictions that emerge when you try to model an electron like a planet going around the sun. But this was kind of the original idea, and frankly, I think this is kind of the idea that is the most mainstream way of viewing an atom. Now, I said an atom is philosophically interesting. Why is it philosophically interesting? Because what we now view as the accepted way of viewing an atom really starts to blur the line between kind of our physical reality and everything in the world is just information. There really isn't any such thing as true matter or true particles as the way we define them in our everyday life. For me, a particle, it's like a grain of sand. I can pick it up, touch it. While a wave, that could be like a sound wave. It could be this change in energy over time. But we'll learn, especially when we do quantum mechanics, that it all gets jumbled up as we start approaching the scales or the size of an atom. But anyway, I said this was an incorrect way of viewing it. What's the correct way? So it turns out, let's see, this is a picture. Not a picture, really. This is also a depiction. So it's an interesting question what I just said. how can you have a picture of an atom? Because it actually turns out that most wavelengths of light especially the visible wavelengths of light, are much larger than the size of an atom. So it's not like something you can even, everything else we quote unquote observe in life, it's by reflected light. But all of a